Okay, let's go ahead and start. You had last week off for spring break from us, and I think also our school's closed too, right? So that's what I was thinking the schedule was that y'all were on. Every school system across Georgia is different on it. I've got some associations with some different ones. Where I live in South Georgia, that the school systems down there are all this week. So, if I sound a little confused on that, that's why. And I was, before we were out last week, I was completely caught up on grading out there. Transferring grades, I'm a little behind on that between the two systems. I'm going to try to work on that a little bit later today. Depends on what all I end up having to do. I know I've got some advisement to do today, and I got a couple other things going on. But that's one of the items on my list to try to get accomplished. Besides, I've also got another class to teach at 1 o'clock and such. So it's easier to do that when I'm using my 2 screens set up at the office than from home, where I can get 2 screens. We have a second screen, but it doesn't sit beside it, so it doesn't work quite as well. It sits above it, and that makes it a little trickier. It's easier right beside it. And that I was trying to take off some time for myself last week also. I did get my second vaccine shot last week, and then that picked up things a little bit because I did that Tuesday morning, and then Wednesday my body reacted to it. Didn't stop me, but it definitely slowed me down, and then I had a fever that day and aches and pains from that. And then I've been okay since, other than just like the first one, the second one, the spot was sore for several more days. Although soreness is gone now. So that goofed up on my break on me. And then, so I'm going to try to work on some grading today of stuff that's due this week. But if you're behind on turning things in, you need to get them turned in as quickly as possible. This chapter is short, so Wednesday, I will give y'all a chance again to work on your cabling lab, those that still need to do it. I know there's a number in this class that do need it still to finish it. And to work on other labs where y'all can ask me questions here in the classroom on it. Okay, because this is really a short little chapter. I probably, when I laid it out, I really didn't look carefully at it apparently, and I should have combined this one with the next one, although all of these are going to be shorter coming on down at this point. So it really doesn't make a big difference. Whatever I did, it's going to end up with a short chapter. This chapters you just went through on IPv6 and IPv4, particularly the IPv4 one, were really heavy chapters and had a lot more stuff in them. But from here on to the finish, the stuff gets lighter. But that goes back to also where I told you about on these upper layers, there's not as much detail on it, okay? That layer 2 and 2 and 3 are the ones where you get the heaviest stuff in the whole course. And then also just before we got into the layers, when you learned about what the layers were. So that's where your heaviest part was. So again, so if you turned in stuff last week, I'm gonna not really, I haven't seen it and I won't be working on it till at best today. Okay. Because it was a chance for faculty to take time off too, although I did work, I think, every day last week, at least an hour. I wasn't on campus, but for a few minutes one day, that I was doing some other stuff and answering questions, etc. from some people. So that's where we're going from here, is that we'll continue on these. You do have this week, you do have a test to take. Because you've got the test on 11 through 13, I believe it is, which we covered up IPD 4 and 6, and now the ICMP. So ICMP is what we're talking about in chapter 13. And actually, basically, whether you're using IPD 6 or IPD 4, ICMP is going to basically work the same thing on both. So you've not got an issue here of needing to learn something one way on one and something different on the other one. It's essentially the same. Obviously, your packet is going to change on both between the two of them because of the address difference on it. But as far as the command that you're going to use, it's going to be the same. Now, with ICMP, which is Internet Control Message Protocol, so a lot of it is messages that's internal, but you're going to use ICMP also as a network person. And even if you don't go work on networks, that you may well use ICMP. So that the big thing it's going to do is where you're going to use ping commands and traceroute commands. And traceroute command is really a glorified ping command. Okay. Now, ping command does have some differences depending on which OS you're using when you do it. So it's got, if you're doing it within Cisco's iOS, or you're doing it within Unix/Linux, you've got more capabilities in ping than if you do ping from within Windows. Okay? Windows gives you a very simple one on it. Traceroute is going to be one of those commands that varies by which operating system we're using it on, of what the actual name is. It's going to be pronounced traceroute either way, but if you're using it on Windows, it's going to be traceRT, where on all of the others is going to be spelled out RETE. So it's going to be traceroute. There's a reason for that. Windows comes from DOS. Actually, DOS grew off of Unix, but it put limitations on it that weren't there and aren't there in Unix, Linux, or any of those other things. Okay. Your file names were limited in DOS to 8 characters. And that also meant your commands were limited to 8 characters because they in turn called a file. So you were stuck with 8 characters. So when they went to put the traceroute command into Windows, They couldn't spell it out as TRACEROUTE. That's more than 8 characters. So their solution was they shortened it up to trace RT. Okay. But ICMP is going to be used to for us to determine a lot of, can we reach other hosts, or are the other hosts available to us? Okay. And so we'll be able to use it to do that. So we're going to use a ping command normally to do that, although we can use traceroute also. But what traceroute's going to do, ping is going to send a request, it'll send an echo request, and to the other machine. The other machine will reply back with an echo reply. So it's very simple and very basic. Okay. If you get a reply back, you know you've got connectivity to that machine. Okay. If you don't get a reply back, you know for some reason you don't have full connectivity there. Okay. And that's all it tells you. The other part is on traceroute, not traceroute, on ping is going to do it repetitive times, because when you try to contact another spot, it's possible that you're going to have one of the times stuff get lost somewhere out there in the Ethernet. So you're going to send, it's going to send a number of messages. Okay. If you're only missing one of those messages out of it, you've not got any real issue. Unless every time you send pings, it always is missing a message, okay? Then you're going, wait a minute, something's not quite said as well as it should be. But normally, if several of them get through and several of them don't get through, no issue about it. It's just, it took it a moment to figure out the correct way to get there. But got it there and got it back. Okay? If you get no replies back, you know you've got an issue. Okay? So with that, it's going to use that approach. So if it tries to reach that other machine, if it comes back and says it's reachable, it's just going to give you a reply on that. Now, how it displays that will vary according to the operating system. Okay? So that sometimes it is, in Windows, it gives you a little message there that says it took so long, and this is the number of milliseconds it took for it to travel down there and back, and that you did receive a reply. On Cisco, when you try it in there, it gives you, if I'm remembering correctly, an explanation point to show that it was successful on it, and if it wasn't successful, you just get a dot there. Okay? So depending on which OS you're on, what information it's going to give you and how it's going to show you that it was successful is going to vary on it. Okay? But in the Cisco iOS, unless you tell it you want additional information, it keeps it very basic. Windows gives you a little more on the automatic basic command, okay? That it tells you how long it took and that it was successful or not, okay? And gives you different codes on it. If it's not reachable there, ICMP version 4 and version 6 give some different messages back to you, but they're basically the same thing. That they're giving you the same type information there, but they've got it a little bit different between them. So, and how they describe it. so that the message 0 on it, the status of 0, and ICMP4 says the network is unreachable. If it's a 1, it's the host unreachable. And ICMP version 6, 0 says there's no route to the destination. Well, that's similar to the network unreachable, but it's got a term differently. A 1 says communication with the destination's administratively prohibited. So you've gotten close to it apparently, and then you hit a block that said you can't go any further. Okay, so it was blocked out. And then the others are about whether it's the protocol or port is the issue. Time exceeded is an indication to you in both cases of you couldn't get there. That if it tells you time to live was exceeded, then you couldn't reach it, okay, in that time period. Now that doesn't mean that it was unreachable, but it's basically unreachable for you. But it might be, but there's no short enough route to get you there, and so it's not going to be a usable connection anyway. Okay, so you're going to use ping to test and see when you've got problems on your network to see what can you reach contact with, so that if he says that his machine's not working now, he can't get on the internet, you could do a ping command, and it might be him do it, it might be he calls help desk, they may tell him to do it, or if the worker comes, the support person comes and looks at it, the first thing they may well do is do a ping. Okay, actually do a set of pings to figure out what is not working about his internet. And that's a common call to help desk. My internet's not working. Okay, is it really the internet, or is it the network is where we are, or is it actually just that machine? Okay, so you're going to do several different, normally for that, you're going to do several different diagnostics on top of it. Now, which direction you choose to go in, that just depends on the person. And actually, like in my case, it depends on what I'm thinking when I sit down at it, or it might be what I've heard or something else on it, which way I want to go. Because you're usually going to start either checking from the machine to see is the machine able to talk to the network, and then see if it can talk to somebody else on the network, and then go out onto the internet. Or you're going to start from the other end and try something out on the internet. If that doesn't work, try something closer, and then try something within your network, and try something and see if you can even hit the network off your machine. Okay, so you're going to usually work one way or the other, and which way you work, that's up to the individual. So everybody follow that part? And so each of you, that could vary. Okay, so you're sending that message, and then you're getting some type of information back. Were you able to reach whatever you were trying to reach? We mentioned on ICMP4 about it using echo request and echo replies. In ICMPv6, it's going to actually use router solicitations and router advertisements. Okay, and also network solicitation and network advertisements, and that's going to be used in terms of inside, and that's not what we're going to be using as humans, but the machines are sitting there talking to each other all the time, remember, and that's where they're going to find out what else is out there. So the router solicitation is going to let us know it's going to be trying to find out what other routers are around it. Router advertisement is when it tells the router sends out a message, an ICMP message, and says, I'm here. All I need to know that I'm here, okay? And then the network solicitation and the network advertisement is the same type of thing. It's looking to see what networks are attached with it, or broadcasting to the others that it's got one network sitting on this interface and it's sending out to these other interfaces. I know about this network is connected to me, and it's telling these others, anything else that's connected on them. Likewise, it's listening to other routers, tell it about networks they have connected. And then they can build their routing tables off of that information. And so then we can get information faster too. So with ping, you're testing connectivity. And in its simplest form, all you're going to do is do ping, and then either the IP address or the DNS name for the device you're wanting to check connectivity to. If you do ping to a domain name, okay, to the DNS name of the device, the first thing it's going to do is go out and use DNS to find the IP address, and then it will actually send the ping. Y'all follow on that? So if you do ping www.dwightwatt.com, it's not going to send out the ICMP echo request. It's not going to be sent to www.dwightwatt.com, but it's going to first go out and look and see what is the IP address for www.dwightwatt.com and send a message to there. Y'all follow on that? Which means when you do ping www.dwightwatt.com, it will actually tell you what the IP address is for www.dwightwatt.com. Y'all follow on that? So you can actually use ping as a way to look up IP addresses. Okay? So it's going to do that, and then it's going to send the ping out there. And send it. It's got a timeout value on it that it's going to automatically assign on it. Like I say, it is going to do the ARC or network discovery is the first part of it, okay? When we ping on it, we can ping our loopback address on our machine, which in IPv4, we said is what addresses? What do they start with? IPv4. Huh?
The loopback addresses.
I couldn't hear you.
I said, what you were asked what the loopback address is.
And IPv4. What number is it?
192.
No.
Nope.
170?
Huh?
170?
Not 170. I don't know what 170 is for.
No, not 170, 172.
No, not 172. 172 is Class B. Remember where we said about there was a huge wastage of addresses in IPv4?
Oh yeah, it had a whole bunch
Because
of.
we assigned an entire network in one class to loopback. And that was 127, which is a Class A address. Okay? So you can do ping 127.0.0.1 is what's most normally done, but it could be ping 127. Whatever, as long as it's between 0 and 255, other than the last one's got to be between 1 and 254. Okay? So that will tell you, and actually if you do that on your machine, what it's doing is it goes and tests your network connection on your device, okay? Used to be it went and tested your network card. Well, now you don't have a separate network card in there, but it's really still connecting, checking that NIC to make sure the NIC is there, okay? Y'all follow on that? It's not going out onto the network. It's just checking to see, have we got a network interface on our device? Do we follow that part? So you'll know whether that's working or not, okay? If you want to see if it is actually connecting to the outside, you got to test using its address, okay? But if you ping 127.0.0.1, you're going to know that you've got a turned on networking device, okay? Y'all follow on that? It's like your wireless ones, y'all can turn those off, remember, okay? It could be broken. So there's what all could be going on. So where we had Nathaniel calling about his internet's not working, if that's down, internet's not going to work because you can't get out anything, okay? And it's got nothing to do with the internet. It's his local machine. Y'all follow on that? So you can ping that. Now, if you were doing it in IPv6, what would you use for the loopback address? So the one IPv6 address that I gave you. I just gave you the answer too. So it was : 1. Okay. And that will do your loopback address from IPv6. Because in IPv6, it's only got that one single address for a loopback. Okay. They didn't waste a whole bunch of addresses that they're not using. So we can ping that loopback. We can ping our default gateway. You can obviously go in and look with ipconfig and see what the default gateway is, or go look at the settings. Okay. So then you know, can you get out? Can you reach the out point of how you get out of your network? Okay. And that's all that's telling you. Okay. So is your network actually connected to another network? So is Nathaniel's network actually connected out? Because we first sat there, probably figured out that, yeah, we could ping his loop back. So we went, okay, so his network interface is working. And then we pinged something else that maybe he pinged her machine and he got a response back. And it's on the same network, so going, okay, her network's working. Then if you ping the default gateway, you're going to find out, can you reach the spot to get out onto the internet? If you can't hit that, you're not connected to the internet, and you're not going to get anything on the internet. Y'all follow? And then obviously you can ping remote host. And that, my example continuously quite often is my one. Quite often what's used on that is that people quite often will ping CNN. That's a short little name. Ping CNN.com. Not a whole lot of typing to it, and that we know that site's up all the time. Because the other issue is when you're pinging remote sites, is the site up? It could be down. The sites do go down. That CNN has got themselves replicated all over the place. So if something went down someplace, it should still be able to reach it. Okay. And that so that they've got it designed to handle extra heavy volume when things happen out there. It's not always been that way. Back when 9/11 occurred, most of the sites like CNN went down in it. Not because they were damaged by 9/11 occurring, because everybody was all of a sudden logging on, traffic they'd never seen on the internet before was clobbering them and their stuff got overwhelmed. Okay? So then the question was hitting alternative ones that not everybody knew about, to go try it and you could get information. Since then, they've built themselves much more because that was an awakening to them of how much traffic could actually be out there. Now, that doesn't mean that if something like that happened again, that with how much more everybody's checking everything now, whether they're really fully prepared for that or not, we don't know. Okay? So the other thing is, so you can ping your remote host and do all of that. Now, when we mentioned ICMP briefly before, I mentioned to you it can be abused, and that is a problem with you actually using ICMP, because you can use ICMP using ping to do attacks on networks and on computers, and that's what people do quite often. Okay, and that they'll do denial of service attacks or DOS attacks or DDoS attacks, quite often using ping or using something else within ICMP. Okay, now they do some other techniques also on it, but that's where the most common is on that. And what they'll do, your messages, your ICMP messages actually have a top priority when they are received by networks and computers. Okay, as far as what it's got coming in from the network, it's a top priority thing for it to respond to. That's where it gets abused. So don't do what I'm telling you about, okay? Everybody got that? Don't do this, okay? That you could write code, or you could just start typing them in rapidly, a whole bunch of pings at some place, and lock down their network or their server from being able to do anything, because it's sitting there, all it's doing is answering to your messages, and that then they can't send out stuff, or other stuff coming in doesn't get any response because that's low request. So you've hit some ordering site and you're hitting it with this massive number of pings. Nathaniel wants to order some item. Okay. Another one of you decides to do a DOS attack on the same location. At the same time, Nathaniel trying to order from him. Okay. The other one sending those pings, attacking that site, will lock the site down where when Nathaniel puts his order in, he never gets a response back, and it never gets to handle his request to order whatever it is. Maybe he's got lots of money and he's building this really fancy big new house that's going to cost $1 million, and he's ordering all the materials for it right there. They can't get the order from Nathaniel because the other's going on and has locked it out. Don't follow on that? For that reason, a lot of sites actually block all pings coming in. And that was the way it was done for a good while to respond to that. Just block them out. Because then you didn't have to worry about it. Nathaniel's order comes on through and we get it placed and we can send him the stuff and make our big money off it. With your more newer firewalls and your next generation firewalls and so on, instead of just doing a block of all pings, now you can tell it to do an intelligent blocking on pings. CNN actually does this, okay? So you can actually ping CNN still now, okay? What it does is it says, okay, I will let in 5, 7 pings from a location. If I get more than that, I'm gonna block. Don't follow? Because when you send a ping request out, it actually sends 4 or 5 as default, okay? Because remember I said one of them could get lost in process, so that's why you normally send by default, just a ping come in without telling anything different, it's gonna send 4 or 5 pings actually for that one ping. Y'all follow on that? So it looks at it and says, okay, I just got a couple in from there. That's no problem. But if all of a sudden it's getting more than that, it's going to block out pings from wherever it is, and that keeps it from locking it down, but also you can verify you can actually get connectivity to the location and that you know it really works. And that your machine, when it's doing its contact behind the scenes, also knows things are working too. And so it's still there, but it's not, okay? Now, so that means some places you may ping to, you may actually have connectivity when it tells you you don't, okay? But the ping doesn't get any, does not show connectivity. Does everybody follow on that? Because ping is used, okay? But don't go out and do a DOS attack or a DDoS attack. A DDoS attack is just a distributed denial of service attack. And what it did was, a DOS attack took the approach of it was just coming from one place. Susie sitting on the back row. And there's nobody sitting on the back row, okay? Decided to do a DOS attack on school. And sits there and proceeds to send out a whole bunch of pings at school, writes a short little script. And that's what they do. You just write a script in JavaScript or Visual Basic or whatever, or Python or whatever language, and just set it into a huge loop or continuous loop usually that just sends out pings. And so it's sending ping after ping after ping after ping after ping. Y'all follow on that? So actually Susie's not sitting there doing anything other than said, run this DOS attack, okay? Well, obviously the solution on that one, if you came under attack, once you realized you were coming under attack, is block traffic from the location it's coming from. And if you just block the traffic coming from that location, you've then freed up and stopped the attack, okay? Well, the hackers figured out their way to get around that one. Because remember, cybersecurity is a continuous issue of blue team versus red team and which one's ahead of the other. And that the red team then figured out how to get ahead of the blue team. So the blue team's defending it, the red team's attacking it. But they then went and figured out, well, wait a minute. Instead of just sending it from one spot, that Susie then sends out bots and puts on different machines all over the place a program and has it set that on such and such time on a certain day, it's going to ultimately run. And so the attacks are going to come in from all over the place. Well, obviously that gets harder to defend on it, right? Because you've got to then try blocking out all pings, but get some traffic through and realizing, remember, that your networks are talking to each other using pings. So now they're not going to be able to talk with each other and be well aware of you. So it's going to put some limitations on what you can do. But it makes it much harder to defend against it then, because it's coming from multiple places. It's just like if we were fighting a regular fight out there, warfare battle. If the opposition troops are only firing from one location, that's easy for us to then attack them back, right? We just fire away at that location. But if shots come in from all around, we got to be shooting at multiple places and hoping we're getting where they're going to come from. Okay? So, I say for a while there, they got very hard to use the ping command. There's a lot of places still one, block pings coming in, and then there's a number of places that will not let you run pings on their network. I don't know, I mean, I'm thinking it is this case at the school. If we were this way, and I think we're still are, I don't think you can ping from in the school. Okay? That if you try to ping from here, ping somewhere else, it's not gonna work for you.
I think
But
we
it's
actually
gonna-
have pinged in here.
Can you?
Yeah, I think
Okay,
in the other class, I think we have pinged.
okay, so it did let y'all ping out on it? Okay. For a good while, they didn't, but apparently they've now made it a little bit better. If you go home and you try to ping the school website, or to ping the school address at the school, the last I knew, it didn't work, but it may be working now based on what y'all are saying, okay? Because they've got better firewalls, and whether they set the rules up on that using, and some of them actually come with it built in where they now allow but block on multiple, so then people don't even need to worry about trying to set it up, okay? But I know the school wouldn't let you do one for a good while, which we kept trying to tell them we really need it in our classes, okay? So that y'all can try it and see what happens. Not to try to do a DOS attack, but to know how to use ping to do its work. All right, so it's going to give you that information. Traceroute does the same thing as ping, but every time it crosses a router along the way, it sends a reply back. Does everybody follow that? Ping only does a reply when it gets to the end. Okay? Traceroute, as it travels, it will send a reply back from each router it crosses. Y'all follow that? That means with Traceroute, you can actually see what's the route it took from here to CNN, for instance, which their biggest servers are sitting in Atlanta, obviously, okay? And then in New York. Well, the question is, we're sitting here in Ringgold. If you did Traceroute to CNN, is it going to go straight to Atlanta, or is it going to do a strange distance out, goes out to Los Angeles and back? And that's possible, okay? Traceroute will let you know that. Now, it's not always as obvious on where you're going through on Traceroute as it used to be. Because routers used to be well recognizable, that you named them and showed on them something about the organization that they were with, and a lot of times and such, and so they gave away where they were and whose router it was and such. But now a lot of them don't give any information in the names on them, so you're limited on what it's telling you. But it can still get you an idea of the route. It also will tell you how many routers did it go through to get there. And remember, that's the issue in time to live. That time to live usually is counting the number of routers that it gets to go somewhere. So if it's pushing up to 30, you know, you've got a slight little problem there getting to that location that you're pushing the limits on. Okay? And if it's a smaller number, you know, you're going to get a much quicker back response on it. You follow that? So Traceroute is just telling you exactly the routers you go through to get from one place to another. So it's tracing them. So you did a ping. We did a ping to CNN. That Nathaniel called our help desk and we told them, all right, ping the other. We figured out that we could get out to the internet. But we pinged CNN and it didn't work. But we know we're good through the gateway. Okay? We can do a trace route to CNN then and see and let him tell us what routers it went through. And we can find out, okay, it went through the routers within the school, and then it went through the router at TCSG in Atlanta, and then it went through something else, and it went to another, and then it's retired. Okay. Were we still within the school network? We can figure that one out. Is it something we can fix? Is it something that when it's reaching out, going through the ISP that we're using? Is it the ISP is down? We can figure that one out from there. So do we need to pick up the phone and call the ISP and tell them, I've got a problem? Or is it on beyond there and we haven't got any control about it? But once it gets that into the wild world out there, that's not our control, and we don't have any place to call about that. That's other people's control, okay? It gets into the backbone, and then when it gets on down to CNN's bit, and it may have even shown us that it hit CNN's router and then it didn't go anywhere. Well, in which case we know CNN's got a problem. That their machine, the server is trying to hit, it's unavailable for some reason, but we can actually hit their network. So they got a problem at that point. So traceroute's going to run it through and find their whole way through to everything. That there is a chapter. I told you it was a short chapter. I've added a good little bit of information. Those DOS attacks are not covered in here from what I see. Okay. But that's a whole description on it of what you've got. But traceroute and ping are very good tools to use. However, because they are tools that have been abused, they may not always work for you. Does everybody follow on that? But they're still the biggest tools in terms of looking for connectivity you got out there. Questions on all of that? All right. Then we still got about 40 minutes. So let's today do the same as I said we'll do on Wednesday. Go ahead and sit there if you've got labs to work on, and I know some of you may well be caught up on some stuff. Probably more likely of those in here than the ones that aren't here. That's usually the way it works. And that y'all can work on that. If you know you're still needing to make a rollover table or whatever, you go ahead and work on that right now. Okay? Any questions on all of that? So we follow on that? So let's, for the next 30 minutes or so, sit here and work on stuff I'll be glad to answer questions and help y'all with, and that you've got, because I know some of you in the class don't have the tracer available to you to work on outside of class. So here's your chance to work on it, okay? And let's make sure we're getting it all done. Because we are down to the last month now, but if I'm remembering right, May the 5th, I think, is your final exam is due. Okay. And actually the final exam will be available online from that Saturday, something like May 2nd through Tuesday, May the 5th, if I'm remembering, okay? Correctly. Now that's dates off the top of my head, so don't hold me exactly on those numbers, but it is Saturday through Tuesday. I will tell you that for sure. Okay, so for sure that Monday you'll have, which I think is May the 4th, you'll have to do working on doing your lab final to get your tables made in here. But remember, you've got to do the tables at the end with no assistance. Okay, and probably that Wednesday before we'll work on them also. Okay, so that Wednesday and Monday there.
The final exam is the 1st to the 4th.
The 1st through the
4th.
4th, okay.
The 1st to the 4th.
Okay.
So.
But that should be Saturday through Tuesday, is that correct?
Yes.
Okay. Trying to remember all those number dates all mixed in there. for the Midler issue. But first would make sense, because now when I think about it, on the 8th, I'm supposed to be taking pictures of a 5K run in South Georgia on that morning. So that would make Saturday the 1st, okay? So mixing those all together is the trick. Any questions? The test is active out there that is due next Monday on 11 through 13, because I did activate it yesterday. So it should be there active for you and that kid. Because I know I did activate it, because I distinctly remember activating it for your class and also the other class, but I distinctly remember putting the steps on it in here. It seems like it looks everything we get that there. And it feels like it's going to be one. So I'm going to stop video, because there's no reason you can video this one.